to the side here, draw in one circle just so we can define these one more time. And I'm going to do the central angle first because that should make the most sense. Central meaning the center, so put a dot at the center of the circle. And then just make an angle from that point. So that means I need to have two different R's coming out of it. Notice how we now have a center angle. All right, that's what a central angle is. Okay. An inscribed angle is an angle that is actually on the circle itself. All right, so if we come over here, let's not do it on that. No, I'm going to screw it up here. So that's our central angle. We'll just do the inscribed angle here. So let's say I do an angle that's on the circle. And then let's say that we extend from there. Now notice we have another angle that we just created right here. So we have two angles. One of them is, if you think of kind of in or on, it's on the circle. It's actually in the circle itself. And then we extend an angle from that. The central angle is there. What is going to happen in most of the problems today is, let's say, so now come over here, draw in a central angle like so. Make it a little bit wider. And then put some big red dots where that intercepts the arc. Morning, son. And then what you're going to do now is put another dot right here and draw an inscribed angle out to the exact same 2 points that the central angle created. So now we have both. We have the inscribed angle right here. We have the central angle right here. And then notice how they both, when they hit the circle, create this arc right here. So one more quick definition. This purple is called the intercepted arc. Any portion of the circle is called the arc of that circle. Okay? And we have an inscribed and we have a central angle. So what we're going to do real quick, and I'll show you how this gets done, just so we can save a little bit of time here. Inscribed versus central angle. So if I now go back to what I had up when you guys came in, this thing is not giving me a nice, perfect angle, whole number. Did I? Oh, okay. There we go. It's very touchy. All right, so here is this intercepted arc, right? It is created by this central angle, and it is created by this inscribed angle. So in our table, when we go to fill this in, the inscribed angle is the angle that's on the circle. So the first one we're going to write down, because I got it to work. The inscribed angle here is this 65-degree angle. Right next to it, they both create this arc from A to B. The intercepted arc is identical. Well, if that is a 65-degree angle in the center, or in the inscribed angle, notice how the central angle is 130. So write that down for this one. So the first one we are putting in is this is 65 for the inscribed angle, and we would have gotten a central angle of 130 degrees. Okay? All right, let me see, because it won't take you too long here. See if I can get another good one. Let's try 150. I'm going to do that. Pretend this says 150, right? That's really, 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 really close to 150. So our inscribed angle is 75. So write that down on our paper. The inscribed angle is 75. And when the inscribed angle is 75, our central angle is 150 degrees. All right. So this will be 150. So one more, and then you'll hopefully realize this is not a coincidence anymore. I'd like to try to get 90. So let me try to get a 90-degree angle. Perfect. I did it. All right. So if that's a 90-degree angle, the inscribed angle is a 45-degree angle. All right. So this is 45, and then this is 90 degrees. All right. So real quick, let's say I don't even show that. Let's say I would have done another one, and I would have created an inscribed angle of 20 degrees. What is this central angle going to be? Good. This would be 40 degrees. Okay. So that's what number 2 gets at. If I knew the inscribed angle, and that's what I just did for Jake. So I'll do one more. If I know the inscribed angle is, let's do 50. The question then is, how would you find the measure of the central angle? What did you just do, Jake? Yeah, you just doubled it to get this. In this case, it would have been 100. So you just double, to use Jake's words, that inscribed angle. All right. All right, now 3, just keep it straight, know the definitions. If I now knew the measure of the central angle, so the central angle is the one on the right. So if I told you the central angle, what have we not done yet? If the central angle was 120, all right, then Joe M, what is that going to be? 60. So if we know the central angle, then we cut in half the central angle to get the inscribed angle. Okay, so one's double the other, one is half of the other. Just know which one you're given, which one we're looking for. It is to some degree just some common sense here, because isn't this a more acute angle than this angle here? So the one that's going to be half is always that inscribed. The one that's going to be the bigger one is going to be your central angle. Okay. All right, so that's 2 and 3. The homework you're going to get here in a moment, you're going to get a lot of questions like this, so we don't want to overthink this. It says, use a diagram to the right to answer the following questions about circle A. The first question is, again, this is an old definition from last week. When you see this thing above it, all right, when you see this is an arc above CB, what that is asking you to do is find the measure of arc CB. That is this here. How many degrees does this arc comprise? So if this is like a pizza, a pie, and we're asking what degree measure does this have to be? It's based on the idea. We haven't actually talked about this together. Everybody should know this. If I actually went all the way around a circle, I don't think we've talked about this. What is the degree measure around an entire circle? We do know that, right, Armando? Okay, so the whole circle is always 360 degrees if we go all the way around. All right, well, if you look at this, whenever we name the dot in the middle, that means this is the center of the circle. Notice how we have a chord drawn through the center of the circle. Well, any chord that goes through the center of a circle is what we call the diameter. Doesn't that diameter cut that circle straight in half if we go through the center? So if I'm asking you what is the measure of arc C or of arc CB, doesn't that have to be half of 360? So we would just cut that in half. That would have to be a 180 degree angle. Okay, so that is what we're going to put there for that answer. If you want to put this into words, we just kind of showed what we did. The full degree measure of a circle is 360. The diameter is cutting that full circle in half. Half of 360 is 180 degrees. Okay, I'm going to move this down to the next page. Hopefully it all goes. Of course it doesn't all go. All right, so now go to this next question. So you'll have to flip it. You'll still have it up here. The next question, so you can look at my picture. The question now is, what is the measure of angle CAB? So first identify that angle, because it's a little weird. So find the angle C to A to B. Then this is a really old idea, but an easy one. This is one that everybody knew when we did it back in the day. Is it angle CAB when you go from C to A to B? When you do that, isn't that what we would have called, isn't it a straight line pretty much? And we actually talked about straight angles back in the day. What did we say the measure of a straight angle is? Anytime we have a straight line, that was always what degree measure, Joe? Good. That is always 180 degrees. Well, look at what that angle also does. This is the angle that creates this intercepted arc. Okay. So the angle is 180. So let's write a 180 degrees right here. The arc that it intersects is 180. That is not a coincidence. So let's go back to this guy. So let's say this purple one, let's say my intercepted arc, that's less than 180 for sure. We'll say this is about, let's say that's an 80 degree measure for this arc. that's going to be the exact same thing as your central angle, okay? That is not a coincidence that when we did this here, the arc measure and the angle measure are the same. Now, the next one's a little sneakier, but we've done this, we should be able to. Tell me that one. So say the measure of angle CDB. All right, so angle from C to D to B should be this angle right here. This on the front page in our table, isn't this what we called our inscribed angle? And just like we did on the front page, isn't this supposed to be 1/2 of that central angle that created that arc? So this had to have been 90 degrees, okay? All right, so the conclusion real quick in number 7, we're actually gonna write a couple of different things. This is asking you about the inscribed angle, whose endpoints are the diameter of the circle. All right, that inscribed angle, if it is the diameter endpoints, diameter is always gonna have a 180-degree measure. That means if that inscribed angle are the endpoints of your diameter, that means the inscribed angle will always be a 90-degree angle, okay? Okay, that's pretty much it. I do want to kind of get you started on this a little bit. Make sure you see some different variations because the homework is a little more, it's not much, but a little sneakier. So Mr. Kubis will give us that, and then we'll do these first couple and see if we're understanding this. All right, when you get it, we're going to start with number 2 because number 2 I think is the nicest one to start with. Okay, so go to number 2. It just says find the value of the angle or the intercepted arc indicated by the figure below. So if you look at number 2, there's 4 things that we ultimately want. Don't worry about these questions yet. We're just going to fill in everything that we can conclude on this graph. We're going to fill that in, okay? So as you look at this, what you were given right here is that this here is a central angle. So what we just talked about, what we just did a number of, if that is the central angle degree measure of 50, the thing we can then do very quickly is go to this intercepted arc. I made this nice and big for you so I can fit it. I can go to this intercepted arc right here. Doesn't that guy have to now be 25 degrees? Okay, so we know that's a 25-degree angle. The other thing that we talked about that we just did, whatever the central angle is here, the intercepted is half of it, but whatever the central angle is, that is also how many degrees of the circle that the arc that it creates takes up. So we know from G to H is a 50-degree angle. And then the last thing we need to know what is the degree measure of this guy here. All right, we'll think about what we just did. Let me find one more color. We'll do, what have we not used yet? We'll do red. Let me finish this arc. If I combine my red arc, my blue arc, and purple arc, doesn't that give you the full 360 degrees around the circle? Okay, well, it's a full 360, but let's subtract away the 155. That would get rid of the red arc. If I subtract away the 50, that gets rid of the blue one. Wouldn't the remaining degree measure have to be what's left over for that purple arc? All right, so if we did that, what is that, 205? So 155? Somebody check me on that. 155? Okay. So this purple arc has to be 155 degrees. All right. Now that we have those, we can answer these questions. You're going to do it on your paper below. I want to leave this nice and blown up so there's a nice visual there. Where is it? All right, so on yours, the first question is asking you in letter A there, find the measure of arc EH. So again, remember, if there's only two letters, again, we're revisiting some things that we haven't talked about since we started all of this. If there's only two letters, that is your minor arc. It is the smaller arc. So I can get from E to H with the purple arc, or I can get from E to the H with the red and the blue. But since there's two letters, we want the shorter arc, the minor arc. So that is our purple arc. You would tell me that the measure of arc EH is that 155 degree angle. Again, two letters means you want the shorter arc. All right, in your letter B is asking, find the measure of, notice how there are now three letters, E, H, G. So this should now be a major arc. So now you're going to go from E to H to G. So doesn't E start here? Here is your H, here is your G. So wouldn't EHG just be the sum of the purple and the blue arcs? All right, so we're going to add those up. Those would have to add up to be 205 degrees. Okay. Letter C, find the measure of angle GEH. We've already done it, but now you're just going to look at it, identify it. GEH was this minor or this intercepted arc or intercepted angle, and that we found to be 25 degrees. And then lastly, the measure of angle GFH. So GFH, that was the one that was given to us. That's the central angle. That is a 50 degree angle. Okay. All right. Yeah, let's go ahead and do this number one now. It's all based on the same stuff. So they're going to get a little sneakier, a little trickier, but it's pretty much the exact same thing that we did in number two. So what I would do is let's just fill in everything that we can conclude about this now. All right. So what we know for sure, one of our new rules is if the central angle here is 110, if we follow that out, it's created by these two lines. So its intercepted arc right here must also be a 110 degree angle. All right, whatever the central angle is, that's how many degrees along the arc we eat up. All right, then from there, we should also, so you do this real quick. The next thing I want you to find is find this guy. What would the measure of this arc have to be? You may need a calculator here. I can need. All right. Let me highlight the one that we know. We know this angle or this arc here is 165, right? So the blue, the pink, and the yellow better add all up to be a 360 degree arc all the way around a circle. So all we need to do is subtract away the two arcs that we knew. All right, and when we do that, did we get 85? We got that. All right, that should be an 85 degree angle or an 85 degree arc. All right, so now that's stuff that hopefully pops into our head quick. Let's go to this. One of these will be really easy. The first one is now easy. Answer that question. Find the measure of the arc drawn from L to N. Know that there's only two letters. The fact that this is arc with two letters from L to N means we want to take the most direct route. So we don't want to take the scenic route all the way around here with the big angle. We want to go from here to here. All right, so Julia, what is that going to be? Good, that's 110 degrees. Now, first one that I think is a little sneaky. see if we can think a little bit. It's not as direct as the ones that we've done so far in the first 20 minutes. Try to answer letter B. So find the angle drawn from O to L to N and tell me what that angle needs to be. The angle that goes from O to L to N. Okay, a little sneaky. Anybody think they're got this today? Clever. Okay, I'm going to draw it in. Here's O going to L, and then from L going to N. So notice how those two lines create this big angle right here. And the reason I'm drawing them in is so that we can see that these two line segments here, don't they create then this purple arc? This is a inscribed angle. The inscribed angle is always what of the arc that it's creating? How do we find that? Okay.
55.
How'd you do that? Okay, so I like what you just said in the sense you're dividing it by 2, but OLN, so look at these red line segments I'm drawing in here, Caden. Those 2 red line segments create this arc right here. So if I want the measure of this angle, which we do, we want half of this guy. That's the one that we want to be cutting in half. Okay. Not quite. If I divide this by 2, so do you have your calculator?
Yeah.
Just do 165, cut it in half. So do divide by 2.
82.5.
Right. So that angle has to be an 82.5 degree angle. Okay. Now, C should be nice. Do C real quick. That should not be a tricky one. B was the first one kind of today. That's a little tricky. So now do OL. That one should be nice. All right, and Ella, what is the measure of arc OL? Good, because that's just the yellow arc. We already identified that as 85. We have it labeled. That's an 85 degree arc. Okay. All right, one more I want to do. Go to number 3. And then at that point, we'll see what we can do on our own. So we want the measure of angle KMS. Actually, do that before we prompt you. Tell me what you think that is. Find the measure of angle from K to M to S. If you're not sure, hang tight. If you think you have it, throw down a best guess. How's it look? Okay. Good. Okay, let's see what we got here. All right, here is the angle KMS. So the angle drawn from K to M and then to S. So what we want to understand and recognize now is when we draw that angle in with those 2 line segments, doesn't it intercept this big arc right here? It creates that as our intercepted arc. The difference is what we've been doing so far, you've been given what this degree measure is. So in the problems before, you would have been told, yeah, that arc is 150 degrees. This is going to be half of that. You're not given that because what you are given is, notice how this is the center. There's a dot indicating here this is your center. And then you have this chord going through this. Isn't this cutting our circle directly in half? So it goes back to the notes. If it's cutting it directly in half, doesn't that blue arc have to be 180 degrees? It's through half of the 360. And if that's 180, then our inscribed angle has to be 1/2 of that. So it's got to be a 90-degree angle. Okay. All right. The next one is a little nicer, a little more direct. If we want the measure of angle MSK, that's this angle right here. That angle is created by this diameter and this chord right here. Doesn't that create the 60-degree arc? So if the arc that it intercepts is 60 degrees, that has to make this angle a 30-degree angle. The inscribed angle is always half of the arc. All right, so that's 30. All right, and then last one. Do letter C. Okay, common question. Hopefully we're getting the hang of that. It's testing you on the idea that you know there were 360 degrees within a circle as we go all the way around. I'm going to subtract away the blue arc. So now all this is gone. We have another 60 degrees right here that we don't need. So we're going to subtract that away. And then whatever remains would have to be the arc that we are looking for, which is the arc drawn from N to S. We do that. What is that? 120 degrees. All right. So we got. Okay. That's it. I want you to kind of try these, look at these, see what we can come up with. If there's any questions, ask. They're all based on those handful of ideas: inscribed angle, central angle, the diameter cutting it in half, and there's 360 degrees. You're going to see some creative ways that these get asked, but it's good. It makes you think a little bit, think on our feet. We'll see what we can do. Okay, if you have any questions, though, let me know. Scoobwits know. Yes, sir. Yeah, go ahead. Yes, sir. Yeah, you can work with somebody. Yeah, that's fine. Yeah, if you want to move and work, you got some time to burn. Makes it take a little bit. Yeah, a little bit. Yeah, maybe. So that's the first one. Yeah. It should be 60. That's 60, 60. Yeah, so you have to think through 66 is 120. That's okay. And so, variable sector. Yep. Yeah, so you're so when we did these, so when this inscribed angle was 25, was the arc 25? What was the arc? Alright, when this inscribed angle was 90, was the arc 90? What was it? How are you, what were you all gonna do? That's 90, how did you know that was 20? Right. This was 25, how did you know that's 50? Aren't you looking at the inscribed angles here? So if this is 59, this is 59, this is gonna be what? Right, so that means that 70 was 10, and then this should not work out. Right? Yes. 59,
Oh, you're on fiber.